All right, grade 6, we're continuing with our unit, but our big idea is changing because we are moving now into equations and equality. So our big idea here is developing and solving equations can help us to solve problems. The concepts we are working on today will be two. One of them is to be able to use symbols and pictures to show and explain the preservation of equality, that both sides of the equation are equal. And that by doing that, we can demonstrate an understanding that by preserving equality, both sides of the equation are equal, an unknown can be found. We can find the unknown number. So this is from lessons 7 and 8 in your textbook. So an equation is kind of like a teeter-totter, as you see here. Both sides need to balance. For example, if you were to put the backpack onto the boy here, this side would go down. In order to make both sides of the equation equal again, we would also need to add the backpack onto the girl as well. So when we look at an equation, it's like a teeter-totter in that both sides should be equal. All right, so when we look at an equation, we don't often think of it as being equal or the same on both sides, but really, if we were to show 4 plus 5 on this side, and then the 5, and if we were to show 9 on the other side, both do have 9 on each side, so it is in fact equal. All right, so knowing what we know now about equality and both sides of an equation being equal, would you then say that both sides here are equal? Assume this is your half. Are both of A equal? Are both of B equal? Take a moment and with your elbow partners, discuss whether or not you determine that both sides are equal. Press pause and do that now. All right, well, let's take a look here. On this side, we have 2 rows of 10, which would be 20. On this side, we have 1 row of 10, and then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, another 10, which would also be 20. So yes, these sides are equal. If we take a look at this next set, B, we have 3 rows of 10, which should be 30. And over here we have 1, 2, 3, 4 rows of 10, which would be 40. So these are not equal. And to show not equal, it's just an equal sign with a diagonal line across, meaning not equal. All right, so your connect section. Then for each of the scales below are balanced. For each balanced scale, the expression in one pan is equal to the expression on the other pan. We use the equal sign to show that two expressions are equal. So let's take a look. 36 divided by 6 is 6. 15 minus 9 is 6. So yes, in fact, they are equal. Here we have 12 plus 5 and 5 plus 12. Commutative property, we already know that it doesn't matter what order they are in, so it will be equal. 17 for 12 plus 5 and 5 plus 12, 17. So they are equal. Here we have 3 and 7 times 3. And again, commutative property applies to multiplication. So we know that 3 times 7 is 21 and 7 times 3 is 21. So both sides are equal. These would all be equal equations, both sides having the same value. When we add two numbers together and their order does not affect the sum, the scales will always balance. This is called the commutative property of addition. Now, we've talked about this already, the commutative property, meaning that the order in which these numbers appear does not make a difference. Now, that only works with addition and with multiplication. Multiplication is also commutative. When we multiply two numbers, their order does not affect the product. Product, remember, is the answer when multiplying. Their order does not affect the product. For example, we can see 3 times 2, 2 times 3, both equal 6. Could even be in variables. We could see that if A were a certain number here and that same number here, say it was 3, B were 4 on both sides, 3 times 4, 4 times 3, both would equal 12. Doesn't matter what number, it applies to any situation when we are multiplying. So commutative property for multiplication and commutative property for addition. This does not apply, however, to subtraction and division. So let's just check. If we were working with subtraction, if I have 9 and I take away 5, can I have 5 and take away 9? Well, no, I can't actually take 9 things away from 5. So commutative property does not apply to subtraction. What about to division? Say I had 35 divided by 5. Would that be equal to 5 divided by 35? So here we're taking 35 and dividing it into 5 groups, which is possible. That is 7. Can we take 5 and divide it into 35 groups and still get 7? No, we cannot. So it is not equal. So the commutative property does not apply to subtraction and division. So sometimes we need to do something to one side in order to preserve equality. We want to keep it equal. When we're preserving something, we're keeping it. So we want to keep it equal. And in order to keep things equal, sometimes we need to do something to one side in order to keep that equality. So let's take a look at this picture. Here we have some tug-of-war teams. At this point, they have an equal mass. Looks like we've got 5 people here, 5 people here. If we now add one more person over here, 48 kilograms, are they still going to be equal? Well, 1 plus 5, is that still 5 people? No. 5 people over here? No. Even if we assume they all weigh the exact same weight, we can see that that will not be preserving equality. So in order to preserve equality, we would have to add another person over here of the same weight. So we would have to add another 48 kilogram person here, assuming they're all 48 kilograms perhaps, in order to preserve or keep that equality. All right, now you're going to try some to see whether or not both sides are equal, and then we'll move on to trying some where we are preserving equality. So, for example, the first one we'll do together. If we have 2 plus 3 plus 5 on one side, that is 2 plus 3 is 5 plus another 5, well, that would be 10. On one side, and on the other side here we have 5 plus 3, which is 8, plus another 2, which would also equal 10. So yes, in fact, this statement is equal. Go ahead and press pause and try B, C, and D with your partner now. Determine if it is in fact equal or not. All right, let's take a look at 6B now. If we have 15 on one side, we don't have to do anything to that side, it is as it is. And on this side we have 3 times 5, which is 15, so yes, they are equal both sides. What about 6C? If we have 3, take away 5. If we have 3 things and we want to take away 5 things, well, let's take a look at this as money. If I have $3 and I owe someone $5, I would still owe them another $2, which grade 6 we know then is actually -2. Going back to our integers from the first unit we did this year. And then we have on the other side 5 take away 3, which is just 2, just +2, which means that no, they are not equal. And then we have 6D here. We have 16 divided by 4 on one side, which is 4. And on the other side we have 3 plus 4, which is 7. Well, definitely not equal. All right, now we're going to move into preserving equality again, where we are trying to have both sides of our equation be equal. We're trying to keep them equal. So often when we have an unknown number, it is represented by a letter. So in this case, it's represented by an N. We want to preserve equality. Both sides of the equation we want to be equal. We can use that to figure out what N should be. So we know that this side is already 21. We don't have to do anything. On this side, in order to keep them equal, which is what the equal sign shows us, that they are in fact both sides equal, what would we have to have times 3 that would equal the 21, that would equal the 21 that is on this side? Well, it would have to be 7. Now let's see if we've preserved equality. 7 times 3 is 21. This side is 21. Yes, it is in fact equal. Now, I'm going to give you a couple of equations that you can do on your own to practice trying to find the unknown using what you know about both sides of an equation being equal and preserving that equality to find out the missing number. All right, well, let's take a look at these questions. So go ahead and do the questions that I've added here in order to find out what the unknown, either the blank or the letter is. Press pause and do that now. All right, let's take a look. So if we want both sides to be equal, we know we have 54 on this side. 6 times something, that's going to equal 54. Well, we could actually use the opposite operation. We could divide by 6 on this side, divide by 6 on this side. So 54 divided by 6 is 9. Is 9 going to work over here? If I had 6 times 9, would that equal then 54? Yes, it would. Which means then we've been able to preserve equality. 54 is on both sides because 54 is 54 and 6 times 9 is 54. They are equal. Let's take a look at the next one. We want it to equal 14. 6 plus what is going to give us 14? And again, sometimes the opposite operation helps. Instead of plus 6 on this side, we're going to go minus 6. 14 minus 6 is 8. Well, let's try. 6 plus 8 is 14. So then both sides are equal because 14, of course, stays 14. Both sides are the same amount. We have preserved equality and we have found out what our unknown number was. Next one, 18 divided by r equals 9. 18 divided by what is going to give us 9? 18 divided by 2 will give us 9. So that means then they are equal. And r equals actually 2. The letter r in that equation would be number 2. All right, those were fairly easy because they were fairly small numbers. What happens when your numbers get larger? Well, we're going to practice with some where the numbers are larger or the answer isn't immediately obvious. So let's try the first one together and then you'll go ahead and do the rest yourself. So again, we have an unknown number, which is C, and we're trying to find out 12 times what is equal to 156. So both sides have to be equal. And our best way to do this is to use the opposite operation. So the opposite of timesing is dividing. So I'm going to divide 12 on this side. And you're welcome to use your calculator to do that. 156 divided by 12, if I punch that into my calculator, is going to equal 13. So then let's see, and let's try this as well in our calculator. 12 times 13, does it truly equal 156? Well, yes, it does. So then both sides are equaling 156, and they are equal. Go ahead and press pause and try the next 3 with your partners. All right, let's take a look at the next few. So here we have 225 divided by r. Well, we can't really take, in this case, we can't take 15 and divide 225 from it, but we can take 225 and divide 15 and see what our missing number would be. which is in fact 15. So that would then mean that 15 times 15 equals 225, which it does. So both sides are equal. All right, for this next one here, we want to do the opposite operation, which would be dividing by 15, and we can take 17 and divide 15 from it, and we would end up with 5. So does 5 times 15 actually equal 75? And yes, it does. So then we do have 75 and 75 on both sides, and it is equal. Last one here, we have 24 minus something, that is 13. And again, we can't take 24 and subtract it from 13. That doesn't actually work. So we're going to have to go 24 minus 13 to see what our missing number is, which is 11. Well, then, does 11 plus 13 equal 24? Yes, it does. So then both sides are equal. We would have 24 and 24 on both sides. Or if we'd done the subtraction, 24 minus 11 does equal 13, and then we would have 13 and 13 on both sides, and it is equal. All right, so we have been able to find out our unknown number using our preservation of equality. By trying to keep both sides equal, we've been able to find out what the letter was. Here we can tell that C is supposed to be 13. Here we figured out that R is supposed to be 15. Here we figured out that D is supposed to be 5. And here we figured out that P is supposed to be 11. So we've used what we know about both sides of an equation being equal in order to determine what that missing number was. You are now moving on to your concept practice, page 35, numbers 1, 2, 3, 4, and 5. Using symbols and pictures to explain the preservation of equality, and using that preservation of equality to find the unknown number. Remember, as you're working, if at any point you have questions, please ask. Seek to be understood by very clearly communicating your work and showing all of your work as well as evidence of your understanding. Away you go.